All right, so we're going to continue the idea of these triangle congruence shortcuts. And the next shortcut is a theorem called side, side, side. And this is actually going to include another theorem that I show you guys called HL, and that's hypotenuse leg. And I'll explain that in example 2. So the next shortcut called side, side, side states if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. So if AB is congruent to DE, BC congruent to EF, and AC congruent to DF, if those 3 corresponding pairs of sides are congruent, then the triangles are congruent. So, for example 1, it's asking, decide whether the congruent statement is true, and it asks us to explain our reasoning. So, for example 1, part 1, when we look at DFG being congruent to HJK, can we say that those 2 triangles are congruent? Yes. We can say that those are congruent by SSS. And my explanation is going to go in this blank at the bottom. If we look at the markings, DF is congruent to HJ, right? FG is congruent to JK. And then finally, DG is congruent to HK. Okay? So that means that those are congruent by side, 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 because each pair of sides that is corresponding is congruent. So that's the main thing we are looking at. For number 2, ACB, CAD. So the first thing I would ask myself, is AC congruent to CA? Which is kind of funky, but if we look at the side with 9 as its length, that's true. That's true. Now let's look at CB and AD. Are those congruent? So CB is this side, AD is this side. Are those congruent? I would say yes. And then finally we look at, is AB congruent to CD? So I'm going to just use a different color to show that. AB, CD, those are not congruent. So, no, not all sides are congruent. So that's an important distinction because we talked about before, for 2 triangles to be congruent, all 3 sides have to be congruent and all 3 corresponding angles have to be congruent. So if a pair of sides are not congruent, then we can't say that the triangles are congruent. So no. And the main reason is because one pair of sides is not congruent. For part 3, same thing, comparing QP and RS. Is QP congruent to RS? QP, RS. I'd say that checks out. PT, is that congruent to ST? PT, ST. They have the same marking, so those are congruent. And then finally QT, congruent to RT. QT and RT, I would say yes. So are those triangles congruent? I would say yes. Write that better. I'll say yes. And they're congruent by side, side, side. So it's me defining what corresponding parts are congruent, and is that enough to call them congruent by side, side, side. So this one I think is the easiest one to pick out. We look at all three sides. Are all three pairs of corresponding sides congruent? The next shortcut or theorem that involves only sides is called the hypotenuse leg theorem. And the concept of a hypotenuse is going to be very important in the future. Also the idea of a leg. But these types of theorems, when this can be applied, is when we have a right angle, okay? So we already know that SAS and SSS are valid methods for proving that triangles are congruent. But what about something called SSA? In general, SSA is not a valid method, kind of shown by these triangles below. If two pairs of sides and a pair of angles not included between them are congruent, the triangles are not congruent. It's because this angle here, angle A is fixed, angle D is fixed, AB and DE are fixed, BC and EF are fixed. But I can change angle B and angle E. I can widen that angle and create two triangles that aren't congruent. So when we say SSA, that is not a congruence theorem. That is not a shortcut we can use. Now, the only time this really works, there's a special case when we have right triangles, and it's called hypotenuse leg. So in a right triangle, the sides attached to the right angle are called the legs, okay? The side opposite from the right angle is the hypotenuse. So that is going to be important to pick that out in our next examples. So, a quick definition of hypotenuse leg. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, they are congruent. So in this triangle, ABC, AB is the hypotenuse, AC is the leg. In the other triangle, DE is the hypotenuse, DF is a leg. So AC and DF are congruent, AB and DE are congruent, and this is a right triangle. So that means that they are congruent. If this were the same situation and these were not right triangles, they would not be congruent. So that's important that it has to be a right triangle and it has to follow a leg and the hypotenuse being congruent. So I'm going to go through example 2 with hypotenuse leg, and I know we aren't totally proficient in proofs, but I want to talk about how to prove something using what's called a paragraph proof, because I feel like that is more of an explanation, okay, and focuses a little less on structure. So this diagram says the television antenna is perpendicular to the plane, so the ground, containing B, C, D, and E. Each of the cables running from the top of the antenna to B, C, and D has the same length, and those are marked. We're proving that all three of these triangles created around the tower are congruent. So it says, given AE is perpendicular to EB, AE is perpendicular to EC, AE is perpendicular to ED. That means all of those angles formed with the ground in the tower are right angles. And then AB, AC, and AD are all congruent. So the fact that we're given those perpendiculars, we can say angle AEB, that's the angle in the back here, AEB, angle AEC, and angle AED are 90-degree angles. Okay? So those angles that form with the tower and the ground are all 90-degree angles. So what that means is, since those are all right angles, that means that triangle AED, triangle AEB, remember the symbol, triangle AEC are right triangles. So that kind of sets the foundation for hypotenuse leg. Okay? That kind of sets our hypotenuse leg up a little bit. So what we've got to do is we've got to define the hypotenuse of each angle. So AD, AB, and AC are all hypotenuses and congruent to each other. Okay? So that gives us the hypotenuse part of hypotenuse leg. Hypotenuse is equal to hypotenuse is equal to hypotenuse. So the other thing we need to do is prove that a leg of each of the triangles is congruent. So if we look at it, all of these triangles share a leg. They all share this leg, and I'm going to highlight in blue. They all share this leg, AE. Okay? So, AE is a leg of all three triangles, and AE is congruent to itself. So AE is congruent in each triangle. So by hypotenuse leg, triangles AEB, or I could say triangle AEB is congruent to triangle AEC, and that's congruent to triangle AED. So most of this was just us seeing that we can prove triangles congruent by the hypotenuse leg by picking out congruent parts of them. Okay? Now, my explanation may not have been the best for this, but mostly what this is us calling out certain pieces and saying which pieces are congruent in order for us to prove hypotenuse leg. So, for the guided practice, good chance for you to pause the video and try to answer this question best you can. In a diagram like this, it might help to redraw the triangles and then use the information to kind of prove that they're congruent by, in this one I'm going to give it away, hypotenuse leg. So take a minute, pause the video. Once you're ready, you can restart the video and I will explain. Alright, so to explain this, I redrew my triangles so that they were kind of matched up. So I put the 90-degree angle at the bottom left when I set up both these triangles. I had the hypotenuse as the top right, side, and then it's realizing I marked it in blue, but this BC and CB, this is what we call a shared side here. So it's congruent to itself. So that means that this side, CB and BC, they're congruent to each other. So the way I explain this is angle B and angle C are 90 degrees because we have that marking for 90 degrees. So that means that these triangles are right triangles. That's the first part of defining hypotenuse leg. And then it's saying leg BC is congruent to leg CB. Those legs are congruent to each other, and each hypotenuse, AC and DB, are congruent to each other. So we can say that those triangles are congruent by hypotenuse leg. So we've got to define that they're right triangles, define the hypotenuse, define the leg, make sure they're congruent, then we can define they're congruent by hypotenuse leg. So now you're ready for your quizzes as your practice. Remember, that takes place of your paper and pencil practice. You can do the paper and pencil practice as an alternative if you want, but you have to share it with me. So that's the idea, is that the paper and pencil practice is what's required when we're in person. The digital practice is what's required when we're virtual. Remember that. The checkpoints, those are another thing that are important for me to grade and put in the grade book so that you can see how you're progressing through the unit. If you need to retake the checkpoints, be in communication with me, or I'll be in communication with you to help you redo those.